Probably on a Pine Valley capture.
Probably.
When you were the division.
Yeah. Did you do like when we caught mountain goats on the beaver?
Oh yeah.
Do you remember that?
We did that too. Yeah.
I was at that
to
one.
move them over to the sows.
Yep. And I remember bringing my kid, and
Yeah.
and I remember you being at that one. But we have a guest today. We're good. We're live.
That was a good. I'm glad we caught all that beginning stuff. That was fun.
Yeah. Yeah, but Brock McMillan? McMillan.
Yeah.
I was telling these guys, you don't have a sister named Tara McMillan, do you?
I do not.
Oh, darn. Yeah, I was in love with this girl in college, as a freshman. Her last name was McMillan. I was hoping maybe it was your sister.
I have a sister, but she's older than me, so she probably wouldn't be in your age range.
Yeah, gotcha.
So you guys go back then? You're talking?
Yeah,
I don't know, 13 years maybe?
Yeah,
Really?
at least. Yeah. So I started in the division probably maybe 06, I want to say. And you've been, how long?
I've been at BYU since 2008.
2008.
Yeah, before that is at Minnesota.
Oh, what part of Minnesota? I was born there.
Mankato.
Okay, I was born in Buffalo.
Oh yeah, so I was at MSU Mankato for 9 years.
Oh yeah, I had a lot of friends that went there.
Yeah.
Small world.
You also went to Kansas, right?
I did graduate work in Kansas, so I lived there 9 years. Yep.
Gotcha. Rock Chalk Jayhawks?
No, I'm a Wildcat all the way.
Oh, you are?
Don't swear at me with that Jayhawk name.
Kansas State.
Kansas State.
Gotcha. Yeah, that's fun, no? Because you got BYU in the same
conference now.
conference.
So all my buddies were going to go to the games together, whether they're there or they're here.
That's pretty
We're going to
cool.
meet and go to the games.
So you did your doctorate there?
I did my doctorate at Kansas State.
And what's it in exactly?
Mammalian ecology. So just ecology of mammals.
Gotcha. How many years did that take? How many years does it take to get a doctorate?
It took forever.
Did it?
So I hunted a lot, like maybe you guys do.
Yeah,
so
that's why I was a fifth year
took an
senior.
extra year or two.
Yep, I did.
If you ask my wife, but it took me 8 years. 3 years for a master, and then another 4.5 for my PhD.
That's pretty good.
Do you ever regret not getting your master's stroke? Because I was about ready to. I was kind of starting to work on my master's project, and then GOHUNT happened, and I.
Yeah, I do. I wished I would have. I guess there's always a chance, maybe, huh?
Yeah.
I don't know if they'd let me back in anymore.
We have plenty of data.
Do you?
Yeah.
You got stuff we could work on?
Absolutely.
Yeah, I would actually genuinely be interested.
Oh yeah.
Maybe
I love data.
Maybe when my kids are so young right now, it feels like all I do is just be a school bus and take care of kids. It'd be hard, but it'd be fun.
Data and research papers.
Brady and I both have backgrounds. So I have a degree from Utah State in biology, wildlife science. And Brady's is in fisheries.
Yeah, fisheries biology. I always wanted to do the fisheries side because I wanted to be able to hunt more still. And fisheries was a great thing where I didn't really have to do it during the hunting season as much. And like big game was always so competitive.
I agree.
It was way easier to do fishery stuff.
So I was actually in the biology department at USU. Okay. So I got my bachelor's there.
Go Aggies.
So
we're
all Aggies.
Last night when we got here, we watched the Aggies play. Huh. They were playing Wyoming, but so you've been at BYU for so long?
16 years now.
16 years.
Yep.
Huh. And you're a research professor?
Yeah, professor of wildlife ecology.
Okay. Mostly working on what?
So my master's degree was on small mammals, and then my PhD was on bison. And then for the first several years of my career, I worked on small mammals up to otters, river otters, some gray wolf stuff in northern Minnesota. Mm-hmm. Then when I came to Utah, I worked on otters again, but the last 13 years has been deer and elk.
Love that.
Yeah.
Which one's your favorite, deer or elk?
Deer. I'm a deer guy. So
yes, used to be my favorite person ever.
I love elk, but mule deer just because I can't get a big one. That's why.
No, I was looking at pictures of you today. You've killed some big ones. You have some big deer.
I've never killed a big deer. I mean, I've killed 8 or 10 mature deer.
Yeah,
but.
Never like that you would call a big deer.
Because I can't pass a 165. That's it.
Nor should you, I think.
Yeah.
Right?
So if it's mature, I think they're all 10s. I don't really look at the score. So if it's made it to 5.5 or 6.5 years old, to me it's a 10.
Absolutely. I wanted to talk about that too, because did you work on a project on aging mule deer?
We did.
On the hoof?
Yep.
What
So we actually age mule deer by the teeth wear.
Yeah.
Yep.
So in the past, everybody said you can't do it effectively by the teeth. You can get yearling, you can get 2-year-old, you can get 3 to 8 or something, and you can get old. And when you run population models, that's generally not good enough to know if it's 2 or 10.
Yeah.
And so we've done it now with thousands of deer, trying to age based on tooth wear, and turns out we're pretty good. So we do have bias, but we know what the bias is. So 1, 2, 3, we're on the money. 4, we start drifting off a little bit. We underage them. And then by the time they're 11, we're saying they're 9 or 10. We're like a whole year and a half off, but it's really consistent. So
we consistently underage them?
So if the animal's 11,
yeah,
we usually classify it as 9 or 10. We don't classify it as 11.
Interesting.
So
I'm not good at this by any means, but when I worked at the division, Jason Nichols, which you know well, he would kind of give me a tutorial on how to age deer based on tooth wear, right? And I've picked up jawbones, and I've showed these guys kind of where I'm talking. But can you give listeners just kind of an idea on what you're looking at when you age deer by teeth?
So by teeth, we typically look at the molars more than the incisors. But the reason is a deer in southern Utah has poorer quality food than deer in northern Utah, and so their incisors wear quicker relative to their molars than a deer, say, in the cache.
Is that because the component of like the sand, the grit in the diet?
And I think it's even the silica in the stems of the plants.
Gotcha.
That's wearing faster. Wow. So all the deer, say, in the Pine Valley, their incisors look older for the same age deer than a deer off the cache. And so we use both, but we generally just use molars. So a 3-year-old deer, the teeth are all still sharp. 2-year-old's easy because the premolars haven't completely replaced. So when they completely replace, then it's easy to tell 2 to 3. 3, they're all still really sharp. They look like they're all brand new. By the time they're 4, they're starting to wear a little bit.
And they wear, the way that Jason explained this, what's the ridge called between, I'm trying to remember, the ridge that runs between the middle of the molar.
Oh, you should have. I knew you were going to ask me that. No, I had no idea.
Yeah, no, that's okay.
I don't know. So I look at them, and there's a dentin line in there. So if you look at the teeth, there's a stained line in the teeth. And a 3-year-old deer, that stained line is just like a pencil line. It's really thin. By the time they're 4, that line is getting to be, I don't know, a little, maybe 3/32 wide. And the teeth aren't sharp. So if you run your finger on them, you can still feel, but they're not feeling like they're going to cut your finger. And by the time they're 5 and 6, they start getting real wear. By the time they're 8, the first molar is cupped out. So
that ridge has completely disappeared.
Not only is it gone, but the molar's worn way down almost to the gum, the first molar, by the time they're 8 years old. And so you can look in there and it'll be cupped way out. That's an 8-year-old deer classic. And the back teeth might still be almost sharp at an 8-year-old deer. But then 9, those back teeth start wearing down, and by the time they're 10 or 11, they're worn flat all the way back.
What's the oldest deer you've seen?
So we're always hesitant to age over about 12 or 13, but we've aged them in the tooth lab at 16.
16-year-old.
The doe or buck?
A doe.
Doe.
Yeah. The bucks don't get that old.
They don't.
I mean, we have had a couple of old bucks, and if it's a cactus buck, they'll get old too because they never rut.
Brady just killed a cactus buck.
He had a shot one in Mexico just literally last week.
That's awesome. So they cactus bucks don't ever breed. Their testes never enlarge. They don't run testosterone. And so they're always fat. They're never running, and they live longer than a.
That's something we instantly noticed is the body size of my cactus buck looked like a deer from Colorado.
Right.
And it was in Sonora, Mexico. Giant bodied deer. Giant head. Like
I thought it would be smaller because it didn't have the testosterone that
I think everything's just going to in its body, right? They're putting all the nutrients.
All the energy's going to growth, and so they're big here too. So, and they're always way fatter. We're just finishing analyses. They're always bigger. They're always fatter. They always have higher survival.
What causes that? Do you know?
That's a great question. So some people think that it's partially their diet. Some people think that they've gone through a bout of disease early in life. Nobody really knows for sure.
Yeah. I'm sure it's hard to study it too, because it's kind of Like, how many deer do you think are out there that are cactus deer?
So it depends on the population.
Yeah.
There's quite a few, like down on the Paunsaugunt, but other parts of the state, you never see one.
And we were kind of talking too, like, do you actually ever see it in elk as often, or like a white-tailed deer? Like,
Yeah, I can't remember ever seeing an elk in full velvet.
I've never seen an elk, and I've never seen a whitetail either.
yeah, it's like, why is it just in mule deer?
Because they're a weaker species.
Come on,
Oh man, don't go there.
I battle with Trail all the time on this. Elk guy to mule deer guy.
And you're an elk guy, Trail.
I like hunting bull. I just like to hunt, but I'll take a big mule deer. Nice
Yeah,
bull.
we're kind of the same. But if I had preference,
mostly I just like to bust Brady's balls a little bit over.
he does.
Yeah,
He really does.
I get it.
It's just kind of fun because he's a diehard. I think elk are made for bow hunting, and I like to bow hunt. So
I mean, we are kind of in like, it seems like a golden age of elk hunting now, because mule deer populations are not doing as great.
Let's maybe talk a little bit about mule deer populations.
Sure.
I'm not even sure how to pose the question exactly, other than maybe just like what's wrong with mule deer?
Nothing's wrong with mule deer. I mean, there does seem to be fewer mule deer on the landscape now than there was 30 years ago, but we have a lot more mule deer on the landscape now than there was 100 years ago.
Yeah. Is it like human expansion, predators, all that mix?
I think it's death by 1,000 cuts, Brady. I think it's roadkill. They get hung up in fences. There's more predators on the landscape now that predicides have been banned. There's more elk on the landscape competing with them.
Yeah.
There's more cattle on the landscape competing with them. Maybe not than there was in the 80s, but than there was historically. And I don't think it's any one of those.
There's a lot of factors.
I think it's a whole bunch of factors.
Compounding.
Yeah.
You said something interesting I wanted to ask you. So you said we have more mule deer than we had 100 years ago. So the peak of mule deer, you're talking the 50s, 60s?
50s, 60s, and then another time in like the 80s.
80s.
Yeah.
Okay. So we had super large populations of mule deer in the 50s, 60s, and maybe the late 80s. Do you think that those populations were essentially overpopulated, if you will? Were those generated from pristine conditions that were set up to produce mule deer, and they probably shouldn't have existed in that number anyway?
Personally, I think yes. I mean, if you look at the history of Utah, there were not very many mule deer. When the settlers first came, it was notable. They'd write in their journal, they went logging today up Cottonwood Canyon. I saw 2 deer.
Right.
It was notable in their journals. Mm-hmm. So I don't think there were very many. And if you look at all, say, the petroglyphs, bighorn sheep are the most common. And we were pretty confident they were really common on the landscape, and mule deer were way less abundant.
Can you talk a little about like what were the conditions, what led up to like those giant populations in the 50s and 60s?
That's a great question.
Do you know?
So
do we know?
I don't think anybody knows. You can make a guess.
Yeah.
And so the guess is that they were being held at low populations somehow. Probably, I used to never say this, but now I think predators had a big role in it. And so they were held at low population size with a really complex predator-prey ecosystem. And then starting in the 20s and 30s, we had widespread use of pesticides, strychnine. Mm-hmm. And I think predator populations, they didn't go to zero, but they went way down. And they were held down all the way till 1973 when those pesticides were banned. Predators were released, and then it took years for them to really come up. And so even in the early 80s, I remember, I'll age myself, I graduated high school in 1983. And that year in my environmental science class, we had a DNR person come in and they said, we think there are 300 to 500 bears in the state of Utah. And now it's probably an order of magnitude, at least more than that. We're in the 5,000 range. And I think it was the same for lions. Mm-hmm. It wasn't necessarily the same for coyotes, but I think for coyotes too, but coyotes are pretty compensatory. They can grow, so there were always coyotes. But bears and lions, I think, were really depressed. It releases deer, and they grew really fast. So when conditions were right, they would grow.
That's interesting because I think, me coming through, Utah State and then working as a habitat biologist, kind of I guess what we were always taught was like we had these ideal habitat conditions. We put a lot of emphasis on talking about habitat where you had grazing, sheep, cattle on the landscape in a much higher number. And they essentially allowed the establishment of browse species to establish because we knocked down the grasses. So we had that establishment. And, mule deer being mostly browsers kind of blew up and flourished from that. But I don't ever remember, like predators being talked about as like, I knew that like we used, strychnine, we used poisons, we poisoned a lot of predators, but I don't know that was ever like a major, talking point for me it was mostly habitat conditions.
Me too. And so, and I would have never said predators before 10 years ago, but now we've been studying it.
Yeah.
To me, there are clear cases where we can say there is top-down regulation in this population. So the South Manti, not right now, but 5 years ago, deer were all fat, low survival. We go in, we monitor what the survival is and what the cause-specific mortality. 19% of the population is being killed every year by lions.
19%.
There's just no way that deer population can grow when you're losing 19% a year to lions.
And that's just the predator aspect, not including anything else.
Right.
Like,
but then you go next door, you go to the Boulder and they have low survival, but it's all about habitat. They're all skinny. They have low overwinter survival. And so units that are pretty close can be regulated by very different things.
Wow.
That's interesting.
So you need to burn the Boulder. If you want to hunt,
I've always
deer and
said
elk
that.
on the Boulder, you need to burn it.
Yeah, I've often, in fact, every year when I worked for the division, I always looked at the Boulder and thinking it's just a matter of time, right? And same with the Penguich Lake. I was like, it's just a matter of time. And then the Penguich Lake finally did catch.
Yeah, look at what it does now.
And we burned 80,000 acres and, look at it, it's doing, much better. I mean, it's probably arguably one of the best elk units, I would say, in the state. And from what I've heard, you maybe know, I think mule deer are doing pretty well on the Penguich.
Mule deer we just trapped elk there.
Yeah.
They're all fat.
Fat and happy.
Every one of them. Like 13 to 19 millimeters of rump fat, some of the fattest elk in the state.
Yeah. And primarily due to that burn, right? You got to think.
Yeah. You look at the Monroe, we trapped them. The Monroe were pretty skinny. So Monroe's this premier unit, and for whatever reason, the elk are not doing nearly as well as on the Penguich.
Kind of touched on predators. I wanted to talk a little bit about, you did this study on the Monroe. Can you kind of outline it? And you split the unit in half, right? You essentially had a north end and a south end, and you did different actions based on the unit. And I would be interested in knowing what you learned. And some of it was predator based, right?
So it was all predator based. So we split the mountain into three regions, the north, the south, and then a middle buffer that we didn't do anything. And so for the first 2 years of the study, Wildlife Services removed coyotes from the north end of the mountain.
Is that aerial gunning?
Aerial gunning.
Gotcha.
I know it's not popular. I've never done it.
You never got to do it?
But the question was, does predator management influence productivity of this herd? Mm-hmm. And so we experimentally manipulated the abundance of coyotes on the north end of the mountain. We did that for 2 years, and then we switched. And we controlled predators on the south and released the north end from that. It's a Baki design. That means before-after control. Mm-hmm. And then each year we captured at least 40 neonates on both ends of the mountain, and we looked at survival of neonates, so newborns. So we'd catch them when they were 1 to 2 days old and monitor them through their life. And it turns out that on that system, coyote control was able to increase survival of neonates from about 45% to 80%.
Oh my gosh.
Like doubled.
Almost doubled. With 2 consecutive years of control. So
what type of control are we talking about? How many
So we'd remove about 70 coyotes a year.
Oh.
So
and I would assume it was targeted, right? Like targeted time frame, targeted elevation.
So right. So that's the other thing that we found, that removing valley coyotes did nothing. You had to be removing the coyotes from the birthing zone. So that 7,500 to 9,500 foot elevation. And if you did that, you could have a real effect if you did it 2 consecutive years in a row. So there's a caveat there, and that is if you do this at a different unit, like on the Book Cliffs, it wouldn't do anything because coyotes aren't a primary predator of neonates on the Book Cliffs.
Is it black bears?
So
Lions?
black bears and lions, and actually lions on the Monroe too.
Yeah.
We were losing, I don't remember, boy, that was a long time ago, Trell, but we were losing 15 or 18% of the fawns that hit the ground to coyotes, and we were losing about 15% of the fawns that hit the ground to lions. And you go to the Book Cliffs, and the lions take 15%, and the bears take 15%, and the coyotes are less. And you go to the cache, and there's hardly any bear take. Lions maybe take 10-15%. Coyotes take quite a few, but then you control there. And so this is the cool thing that we've learned. Every unit
Is different.
That's right.
And how do you figure that out? How do you know?
Because we have adults collared.
Gotcha. Okay.
And we look at survival, and then every time an animal dies as soon as that collar doesn't move for 8 hours, we get an email, and that email says, I'm dead, and here's my GPS location. And then we make an effort to get to it within 48 hours of death to determine the cause of death.
Okay.
And so we've been able to now classify 1,800 deaths of adults, and we've done this with about 700 litters of neonates, and we've classified all the deaths of those neonates. And so we can look at, is the deer fat when we catch her? What's her survival? If she dies, why does she die? What's the size of the offspring when they're born? How does that relate to mom's condition? And then if that offspring dies, what caused its death?
It's fascinating stuff.
It is really interesting.
So good.
And we've done this now for about 8,000 deer.
That's a lot. And elk, right? You've done some elk as well?
So yeah, we just collared 201 elk. So when I say we, I need to put this in here.
Yeah, throw it in there.
This is a big we. So I don't want to make it sound like it's my stuff. It's myself. It's Randy Larson at BYU. It's Dax Mingus at the state of Utah. It's Kent Hersey, the big game project coordinator at the state of Utah. It's all of these sportsmen's groups, like they're putting on the expo here, that provide matching dollars for Pittman Robertson. It's even the average hunter that pays Pittman Robertson tax on his ammunition or firearm.
Yeah.
So it's a big we. I'm one cog in the big wheel machine.
Do you know, are other states doing similar types of studies at all, or is this kind of a Utah thing? Like, are we out ahead of it?
I'm not going to say anything bad about other states. No.
But Utah's doing more, you think?
In general, Colorado and Wyoming do quite a bit of collaring.
Yeah, you see a lot with the migration stuff in Wyoming.
The migration stuff out of the Monteith Lab and Matt Kaufman over in Wyoming, and a bunch of people in Colorado as well. Some of them have the collaring efforts similar to ours. None of them have the cause-specific mortality, to my knowledge, similar to ours. So to me, that's an important piece. Not only do we need to know survival, we need to know why they're dying.
Yeah. So it sounds to me like we're starting to tease that information apart, right? So you're collecting enough data that you can look at almost like a unit-specific basis. Like, what are the bottlenecks? What are the limiting factors on this unit?
Yep.
Are we moving, to your understanding, to a point where we're starting to implement management or hunt strategies based on the information that we collect?
I would say that, yes, that's exactly why we're doing it. So when we were able to see that the South Manti was being limited by top-down predators, the state of Utah came in and they doubled the number of lion tags that they allocated. Now that's a moot point now, but at that time it was very important. They doubled the number, and within 2 years, survival went from high 60s, low 70s, all the way up to high 80s.
Oh, okay. And then I would assume habitat as well, right? So if you're finding, what are you finding as far as fat? Like, what's a fat doe? Like, I've heard that fat does make fat bucks, big bucks. So that's
true. So we've done that study too. Fat does make big bucks. And so we do what's called IFBF, or ingestive free body fat, and it's a formula, but really the primary driver is the thickness of fat on the rump of the animal. And so a fat doe on the cache may be 21 or 22 millimeters, almost a full inch of fat on their entire rump. And we've been able to show that if a doe on the cache on an average winter doesn't have 9 millimeters, she probably isn't going to make it through the winter.
9 millimeters.
Yeah.
So as those deer come in, you're capturing them, you can probably tell if like she's got a death sentence essentially.
That's correct.
Ugh.
Same thing with fawns. We catch fawns, and if a fawn isn't 65 pounds in December, that's like the mean that you have to be to have a 50% chance of making it through an average winter.
Yeah.
And so if we pick up a 51 pound fawn, it's just walking dead. It's not going to make it.
That's crazy that you got that much data that you can just know that.
Yeah.
That's cool.
I'm curious. I want to go back. Don't let me forget. I want to talk about the antler.
The antler.
The antler study. Kind of like average score per age. But I was curious. I've talked to a lot of people. Basically, what I'm going to do is I'm going to pass on questions that people ask me.
Okay.
So last year we had a pretty rough winter, right? Especially through northern Utah, southwest Wyoming, Idaho, southeast Idaho. I've been hearing reports as like as many as 90% of some of the, fawn crop, and then a lot of your adult does as well. How long does a population like that would it take to rebound? People have asked me like, if I plan to hunt Region G in Wyoming, how long should I wait?
So the deer are fat this year.
Okay.
They're going to be throwing big fawns, and that's what we found. So if the deer made it through. Right now, their fawns are pretty big, but especially with how mild this winter's been, they're going to throw big fawns this spring. So they're going to be big bucks in 4 to 5 years.
4 to 5 years. So that's a good one. So from right now, 4 or 5 years from now,
28.
Point Creek.
Yeah.
4 or 5 years.
Well, and it's way more complex than that.
Yeah.
So, maternal condition accounts for only about 5% of antler growth in deer. It counts for about 10% in elk.
Do you know what the difference? Why that is?
So I think that deer are shorter lived, and the maternal effect is not as important as like current conditions or conditions during the growth of that animal. Elk, they're equally important. So, say the average bull, we've looked at about 5,000 elk. The average bull. And this is probably high because these have all come off, say, CWMUs, so they have limited harvest. But on all of those bulls we've looked at, the average score is 321 inches, regardless
Of age.
Once they get to 7, they peak at 7, and they never get any bigger. Now, and I know several listeners are going to say immediately, I've seen a bull blow up. Well, of course that happens.
I was just going to say it.
Same thing with deer. You're going to have an animal blow up. But on average, they peak at 7 years and they don't get bigger on average. So for every deer that jumps from 160 to 190, there's another 4 deer that are the same age that went from 160 to 155.
Yeah, and the likelihood is that buck that is 160 that goes to 190 is probably a 4-year-old deer that goes to 5 versus a 7-year-old deer that's 160.
So I don't know what drives that blow up, because the data suggests that both elk and deer max out at 5 years, elk max out at 6 years, and they're both about 94 or 95% of that at 1 year earlier. So a deer is 95% at 4, and an elk is 95% at 6.
Wow.
And so if you have an elk that has the potential of being like a 380 bull, it's going to already be a 365 at 6 years old, and somebody's going to kill it.
Yeah.
Gotcha. Yeah, that bull I killed in the Manti is 354. He's got a busted fifth, but if he didn't have that busted fifth, he'd be at 354, and he was aged at 7. And I remember thinking, and I've looked at your data, and I remember thinking, oh, this guy, he kind of bucked the trends. He's a little bit bigger than what he ought to be probably for the average, right?
Right. So what that says, I think it says, we're probably squandering a lot of bulls.
Yeah.
Because a lot of bulls are only going to get to 310 or 320, and those are the ones that may not be getting killed on a premium unit. They live out and they die of old age because nobody's going to shoot that 310 or 320.
Yeah, we might be high grading them, right?
So, right. And actually you saw that on the beaver. When they increased the number of tags on the beaver, the average score went down and the average age of harvest went up because people were less selective. They started shooting those 315, 320s that were 8, 9, 10 years old on the landscape.
Right. Man, that's a tough dynamic of managing social expectations and what people desire for a tag and a hunt versus kind of the biology and what, conditions will give you on the ground.
Right. So, I mean, I hear individuals say all the time, I put in for 25 years. I'm not going to shoot anything less than 360. I go, well,
yeah,
you might be going home tag soup because there aren't very many of those out there, depending on the unit you're on.
Yeah. What do you think maybe you don't know, and if you don't, you can just say I don't know. But what do you think the percentage is of like a buck or bull that bucks the trend? Like, is that 10% of the?
Well, I think less than that.
Less.
Yeah. So I think you can get. I don't know the exact number. You can get the occasional 190 and depending on the habitat, maybe a 200-inch buck. I mean, they get shot every year. Mm-hmm. But it's way less than 10%.
It's like finding I killed a 200-inch buck. It's like finding a diamond in the rough. Really?
It really is. It really is. So they're out there. And so the more bucks you leave on the landscape, the more likely there's going to be one to get there unless they start getting density limited. But if you have say a buck that has a potential to be 200 inches, it's 190 inches when it's 4, and it's like 165, 170 inches when it's 3, and so the likelihood of it making to 5 even.
Yeah, it's pretty difficult.
Yeah,
people are just going to
pretty tough.
Harvest it before it gets there.
Can you go back and talk about? I was curious as to what. This is just my own personal interest, but like, what makes a big buck? What has to be genetics? How much?
I don't think genetics has very much to do with it. Yeah.
Oh, I love this discussion already. It's going to be great.
I mean, I don't know that that's for sure, but I think there's enough mixing of genetics between populations that there's not a huge genetic difference between populations. I think it's nutrition, nutrition, and nutrition.
And age.
For sure age. Yeah, for sure age. I mean, I thought that was a given. But age and then nutrition. And not only nutrition of that animal, but nutrition of its mom. So for an elk, the nutrition of mom when that elk was in utero is just as important as the current year.
Oh, right.
So how healthy mom was 8 years ago is just as important as how mild this winter is and how good this next spring, summer is going to be for growing antlers. They both account for about 10%. They account for about 30 inches. And so if you were born to a mom in good shape and you have great conditions to grow this year, you can be like somewhere between 40 and 60 inches bigger than if you were born to a mom that was in poor shape and you're in a poor year.
That's really interesting, isn't it? So you're basically, if you're applying, Brady, what you want to do is look for a year where you have fat does. They're going to have big fawns, and then you want to wait 4 to 5 years.
Yep. Mm-hmm.
That's when you want to be on the landscape and hope one of those fawns made it through.
Is this that same information? Because I read this the other week, and I was just reading in today the paper, Long Lasting Effects of Maternal Condition on Free-Ranging Cervids.
So we did that paper. That was Eric Freeman. He's now a biologist in Southern Idaho.
Yeah, I know Eric.
Yeah, he's
redhead.
Yeah, he's kind of a strawberry blonde head.
Yeah.
Yeah, he's super sharp kid, and
good dude.
And that was some work out of our lab. Yeah,
because I really like that one. I read that one multiple times. Like I said, there's a lot of data.
So, and you can see on the graph in that one that the maternal condition is about the same effect in elk as current year, and for deer, maternal condition only has about half the effect of current year. So the current year is more important for deer than it is for elk.
Yeah, because it's probably depending on their diet, right? Because a deer is more of a specialist than a generalist, and an elk can eat a lot of stuff.
So, and so even when you say there was a lot of browse, that was probably true, but I think even the sheep ate that browse.
Yeah.
I don't know why there was so many deer then.
I'm really fascinated that you're talking about predation. And I think it's cool work that you're doing because I've always been I've always kind of leaned the other way. Like, I think this is more of a habitat, more of a expansion, human population expansion, we're cut off migration corridors. And I've kind of been like, I don't know that it is necessarily predation. So it's interesting to hear.
So I'm not saying it always is. I'm saying it can be.
It can be.
Right. So I think the things you just talked about are really important. But in certain units, it's clear that that's what's affecting it. And so I do not want to tell the story that that's what it is everywhere. We should go scorched earth on predators. In fact, our data say that killing a coyote in the valley or out in the desert does nothing at all.
It has to be targeted.
It has to be targeted in this fawning zone. Coyotes don't have an effect on adults. None.
Okay.
They take a few adults in the late winter, and it's our data suggests that the animals that they're killing in late winter are the exact same ones that are going to die of starvation anyway. So they really have no effect on adults.
Okay.
They only have
fawn
that first 16 weeks of life.
Okay. Do you know much about coyotes as far as like their biology? Is it true what they say that if, you kill a coyote, essentially, the females in the area, the territories will just produce more pups and they'll fill in those territories?
So there is pretty good evidence that that's called compensatory reproduction.
Yeah, I was trying to come up with the name, but
there's pretty good evidence that if you depress the population of coyotes, they can exhibit compensatory reproduction. They increase their average litter size and they have more pups.
Interesting.
Isn't that wild?
Yeah.
What is that? Do you hear that? Somebody trying to get in the front door. My bad. Sorry. Anyway, I was just wanting to make sure that somebody wasn't trying to get in. And then so one thing you said is that you can impact survival rates for a 2-year period.
If you find a unit that population growth is being limited by, say, coyote predation on neonates, then yes, you need to do targeted coyote control for at least 2 years to have a significant increase in survival.
Oh, so at least 2 years.
At least 2 years of control.
That's correct.
And then how long is the impact of survival post? Do we know?
So there does seem to be a little lag effect, but not much. They fill in pretty quickly.
Okay.
But if the population can get ahead of the predator population, then I think they're fine. It doesn't really matter.
Yeah.
So what happens is, say on the Chalk Creek, a couple of years ago, we had a bad winter. We lost 75% of the deer. We didn't lose any of the lions. And now you get what's called a predator pit, because there's still the same abundance of lions on the landscape, but there's only 20% of the deer that are there. And now they can't recover because they're in this predator pit.
Yeah, they can't.
But once the deer get ahead of the lions, then they're generally fine. The lions aren't going to take a significant portion.
Huh? What do you? We're talking predation, talking lions. What do you? Do you have an opinion? Weigh in on Colorado and kind of what they're proposing right now, as far as like eliminating lion hunting altogether, bobcats. What are your predictions as far as what that's going to do?
I have no idea. So we have some evidence trail that mature male lions can regulate the population of lions. So I think what we do in Utah may be
too much,
exactly wrong. And by that I mean, if we're going out and removing only the mature males, we put the lion population into what's called MSY, or maximum sustained yield, and so they're just pumping out lions. Whereas if you leave those dominant males on the landscape, they can control. We have this right on Timpanogos. We have a bunch of lions collared, and we know in one canyon there's been a couple of reproductive events, and toms have come in and killed the whole litters.
Yeah.
And so you have those mature toms. I think they
control the population.
They control the population, but if you remove them, the population can really dramatically increase.
Yeah.
And so I don't know the answer of what's going to happen in Colorado, but I think something like that is better than dabbling. If you're going to, we've been able to show that lions can have an effect. If you want to do something, in my opinion, you'd really need to hit the lions hard. You can't just dabble.
Right. All in or not.
And I'm not saying remove them all.
Yeah.
But I hear people say all the time that we're just wiping them out. Yeah. We tried that with poison for 80 years, and we weren't able to do it. Removing a few is not wiping out the population.
Yeah. That's interesting that you say that, because you probably know Clint Meekum, and hopefully his family won't mind me, throwing his name out there in a hat. But that's what he always told me, and that guy spent more time with lions than anybody I knew, and that's what he always said, is that he thought, having older age class males on the landscape was a good thing, because it essentially kind of took care of the lion population as a whole, because there wasn't this expansion of like younger, juvenile lions cruising the landscape and killing deer. He's like, those big lions will kill those. They kind of regulate it.
So I think Clint McLean probably know as much about lions as anybody.
Yeah.
And rest his soul, Clint.
Yep.
I mean, a great guy. But I think that's true. And the other thing that we've been able to see, we're looking at food habits, and it appears that once a male gets to 4 years old, they kind of switch over to elk too. They don't even hunt deer anymore.
Really?
So these big toms,
they get more bang for your buck.
They get more bang for their buck, and they're regulating the population. So I don't know if this is all true or not. This is speculation based on, 30, 40, 50 colored animals.
Yeah. Man, there's a lot of dynamics, huh? A lot to think about. Do you have something you're going to say?
I was going to jump over to something.
Yeah, do it. Because
I kind of want to jump back to like antler size by age.
Okay.
And as that graphic in that paper, you said you guys, animal had one more year, how big would it be? And basically 4,500 deer were sampled in 5 western states. Average deer only reached 171 inches.
And that's on basically limited entry units.
Yeah.
So this is highly selective harvest. I would say on a general season unit, that's not even true, where you're harvesting a larger percentage.
Yeah.
I would think that it's probably closer to 160 at best is the average size max of a deer.
And that's what's crazy, because everyone thinks, we kind of like pass up those deer.
Right. I hear people say all the time, give that deer one more year.
Give it one more year, it's going to blow up, but data
suggests that that's probably not going to happen.
It just makes me feel good that I've killed a couple big ones on a general
I know, right? It's like
I feel like I hung the moon.
If you're sampling 4,500 deer in 5 western states, and the average is 171 inches. And once they hit 5, they're actually not.
Scenario.
Yeah.
So, I mean, that's not a general season unit. That's in a selective harvest scenario.
That's interesting.
Yeah, that's pretty crazy.
So, I mean, I've killed a lot of deer. I'm king of the 160s.
So it means you're doing something.
You're doing pretty well. It sounds like you're killing 5-year-old deer.
Everyone talks about 200-inch deer, 109-inch deer, bigger than 200-inch deer, but it's like data shows a 171-inch deer potentially could be the average for across these.
Yeah,
I think that's bigger than the average. I really do.
Really?
I mean, that's like off of Deseret and Ensign ranches and Ted Turner ranches, and that's where all those animals came from. They're highly selective. Yeah. They're all guided hunts. They're selecting the cream of the crop, and the average for the cream of the crop is 171 inches.
Do you remember what time frame that study was from that did that?
It was over about 10-year period.
10-year period.
So, yeah, it would have been 2002 or something to 2012, something like that.
And the same thing goes for elk. It was 322 inches. You mentioned that earlier.
Right. So, and that's the cream of the crop on the elk too. So that's, I just think the expectation of 180 is not a realistic expectation unless it's one of like you guys that spend your whole life on the mountain glassing.
Time and effort.
Right. I mean, they're there. I see them every year. Even I hunt the manti. I'll tell you, I hunt the manti, the most heavily hunted unit in the state. And I see a 190 every year.
Yeah.
Seeing one and harvesting one are two completely different stories.
Yeah, that's big country, man. The manti is some big. I had an elk tag there, and man, that is some big country.
And it's steep.
Oh man, it's got some gnarly stuff in it. I wanted to ask, did you follow along with the proposals that the state put together this year in Utah, and kind of that whole process, and essentially antler point restrictions? And I did. I assume. Do you have an opinion that you? How do you feel about it? What do you think? We're trying.
I don't want to upset anybody on that.
No, and I should preface this by saying, like, I've had long discussions. We did a podcast with it. Dax is a good friend of mine.
Okay.
In fact, I've been asked to join this mule deer community.
I heard you were. That's great.
Oh, you did? Yeah.
Oh, rumors spread already.
Rumors spread. Jeez. Yeah. yes, I'm going to join in on that, and hopefully that'll be a fun process to kind of work through and see. But yeah, I was just curious, like, what are your thoughts on antler point restrictions? What do you get from it? How does it work? Does it work?
I'll preface this. I'm a biologist, but I'm also an opportunity guy.
Sure.
Mm-hmm. So personally, I'd rather have the opportunity to be out than
I agree
all the time, because every year there's some good ones out there.
Mm-hmm.
Mm-hmm. Yep.
And so I'd rather be out there and have a chance at one of the good ones than not be out there. Mm-hmm. Even if there's fewer good ones on the landscape. The data that's out there suggests point restrictions are not really effective. Nobody's ever done 4-point or better. People have done 3-point or better. Mm-hmm. I think it could have an opposite effect. There are a bunch of 2-year-old bucks out there that are 4 points, and they're the ones that are going to
get whacked.
Are going to be the ones that are going to get big. Mm-hmm. And I think those are going to be selectively removed because they're going to be vulnerable. Mm-hmm. Mm-hmm.
Yeah, because they're younger, they're dumber.
They're younger, they're dumber, and we're going to be removing the wrong animals at the wrong age class from the population. Mm-hmm. Second thing is, we're just finishing a large-scale 6,000 deer integrated population model on what factors are driving population dynamics. And, of course, weather is the number one thing. So winter, summer drought.
You can say that again. Just reiterate it. Weather, right?
Weather is the number one factor. And that's nothing. We can't control that. Mm-hmm. After you take out winter and drought, it was shown in Colorado, and it was a small sample size. The third thing that comes out in our big population model of 6,000 animals is buck-to-doe ratio. The higher the buck-to-doe ratio, the lower the productivity. Per female, not of the herd. You'd expect if you put more males, there's going to be fewer females.
Sure.
But per female, the lower the productivity. So for every buck you add to the landscape, you lose 2 fawns from the next year's crop per 100 females. So if you increase a population, say from a 15 bucks per 100 does to 25, mm-hmm. the data suggests that you'll change your fawn to doe ratio in December from like 80 to 50.
Gosh.
It makes no sense.
I love this because this is what I've said, but what I've been saying has just been anecdotal. It just made sense to me that if you have a buck on the landscape, that buck is occupying space.
Right.
He's consuming feed that could be consumed by a doe that's going to have a fawn.
Right.
That's going to increase the herd.
So this is what it's suggesting.
And okay, so we have data that
so we have data. So you're on the Mule committee. I'm going to tell you right now, if you're going to implement a study to look at point restrictions mm-hmm. or shortened season dates or primitive weapons, mm-hmm. Fine. Let's try whatever. I'm fine with figuring out what's really works. I think we should also implement a lower
buck-to-doe ratio.
Buck-to-doe ratio. Let's take the manti and double the number of tags. And I know a lot of people are going to be yelling at me right now.
Sure.
Because don't do that to my unit. It's my unit too. But the data suggests that we could increase productivity by a huge amount. And when you go back to the 80s, mm-hmm. on a lot of our populations, post-hunt, there were 9 bucks per 100 does. Mm-hmm. And yet, that's the glory days when there were 9 bucks per 100 does.
What is there a number that you have to have X amount of bucks per 100 does to ensure that population is productive?
There is, but it's small.
Like 5?
So I think nobody knows for sure that I know of, but the number that's thrown out is 8 or 9 bucks per 100 does. We compared populations that were 14 bucks per 100 does to populations that were 25 bucks per 100 does mm-hmm. with this idea of how does buck-to-doe ratio influence productivity. And in both situations, 96% pregnancy. There was no second rut. There was no second birthing season. It was all punctuated on one. Mm-hmm. So down to 12, we know has no effect. And the literature says that number is probably 8 or 9.
Yeah, this is This is interesting. I'm trying to process as you're talking. It's like trying to have a conversation while
well, it's counterintuitive to me too. I mean, it really is.
It is. And I've talked to a number of people that wholeheartedly believe that, the more bucks per does that you have ensures that your bucks, the bucks that are doing the breeding are of a more stratified age class, that they're more healthy, that, every single doe is being bred, but to me, I've always thought it would make sense that if you opened up space, if you removed a buck from the landscape and opened up space and feed for does and fawns, that population would, reproduce and build. So it's interesting to see that we have data.
So the data say that they're all going to be bred and they're all going to be bred on time.
Yeah.
Now there might be, if there's genetic differences among the deer, and I'm not sure there are significant ones. The populations are pretty mixed, even within a population. I'm not sure one buck has significantly different genetics than another. They might. And so, yeah, there's a potential genetic effect if it's not the one with the best genetics that are doing the breeding all the time. So I'm not saying that couldn't happen. It could happen. But nothing that we can measure illustrates that.
Right. Man, that would be wildly unpopular to take a buck-to-doe ratio down to 9.
Yeah, the public
within
would
the
think
state.
of that.
But it might be one of those things that's like, maybe that's a necessary evil for a few years, if you will.
But if your fawn to doe, so back in the 80s, Trail, fawn to doe ratios in this state were in the 80s to 90s every year. So December fawn to doe ratios were 80 to 90. We never get that now. They're always in like the 60s, low 70s, 50s. What's different? And so if we did that and fawn to doe ratios went back up to 90, that's 30 extra deer on the landscape for every 100 animals. 15 of those are bucks.
Right.
So in a unit like the Manti, where there's 5,000 females, you're going to add an extra 1,500 bucks every year onto the landscape, or 750 bucks onto the landscape.
Yeah, that's almost exactly 180 though from what kind of the intent of a lot of these proposals 100%. Are based around, because all the proposals are based around increasing buck-to-doe ratios. So limited weapons, shortened seasons. None of those are, in my opinion, population-based management tools. They're all tools based on buck-to-doe ratios increasing.
Tools for everybody to see more mature bucks.
Sure.
And I'm not against trying them at all. But if we're going to try it, let's try the one that the biology says works too.
I love that. I'm here for it. That's a great idea, actually. Yeah, if we're going to do one, let's do one for one and see what happens.
Yep.
Yeah, let's shorten seasons and go, primitive weapons, but then let's also just open up a unit and double the number of permits and see what happens to the recruitment the next year.
Right.
That's interesting, Brock. You kind of got me thinking now.
Time for you to voice your thoughts on that.
Yeah, we'll find out how it goes. Are you on that committee?
No, I'm not.
Okay.
Randy is.
Randy.
So I think I'm going to come and present deer data to the committee, but I won't be a voting member.
Gotcha.
So
do you know, I don't even know. I'm trying to figure out, I don't even know who's on it yet. I was looking at the email the other day and it looks like I was blind carbon copied on it because I was hoping to go through the emails and see who else was on
Everybody
it.
has been. So I don't know. I know you're on it. I know Randy's on it. I know, who else do I know? Mike Christensen's on it.
Okay. Gotcha. It'd be interesting to see when we show up.
I've heard rumors, so I don't want to throw other names out there of who else might be on it, but it should be a great committee.
Yeah, sounds like I don't know, when Dax called and I started talking about it and I went home and talked to my wife and I was like, I think I'm gonna have to be, if I get put on this committee, but I have to be in Salt Lake and be away from the family and stuff. But I think it's such a, just personally, I'm so interested in mule deer and I'm interested in the longevity of opportunity hunting.
Absolutely.
Specifically for my kids and just, the generations to come, that I'm really genuinely looking forward to the opportunity to participate.
I was on the last one and I thought it was a great experience.
Awesome.
So, it's where we really decide how we're going to manage mule deer for the state and where we're going to take the population.
Yeah. I was curious. You talked about predator management. We used 1080. We killed a lot of coyotes, killed a lot of predators. Is that if we kicked around the idea, is that feasible that we could ever use that again?
I think right now it's federally banned.
Okay.
So I think poison can be used in really specific circumstances, but as a general tool, it's not available.
Think of alternative methods.
So, and again, I would only be in favor of something like that in areas where we've demonstrated that that's the limiting factor.
Sure.
I mean, I'd much rather, like you, I'd much rather see us burning the boulder and doing these habitat treatments. The other thing we've learned is that the summer habitat is probably more important than winter habitat. So doing habitat treatments on summer range is really critical.
That just breaks my little heart, my little habitat heart, all the millions of acres I did on BLM and state.
I don't want to say that's not important because we've been able to show that they lose fat slower on habitat treatments in the winter. But the number one driver of deer survival is how fat they are coming into the winter.
Yeah. Which is where your summer ranges becomes important. I say that in jest. I was just kidding, but I know they're equally. I know that they're both important, but I think it is good that we are acknowledging kind of the limiting factors when they need that fat, coming in the winter, and then we're now looking up the mountain because it makes sense. It's the next logical step.
Right.
If you're going to improve it, you can't just improve one part of it and hope for the best. You got to do both. Hopefully, the Forest Service will just let us do a little burn, huh?
Yeah, well, I'm not getting into that either.
cut through the red tape, right?
Yeah.
It seems like
it seems hard to do it a lot of times.
Yeah.
But I mean, I think there's progress. I think it's going to happen in some of these units.
Yeah, I agree, and I hope so.
I get one.
Yeah.
I want to jump something else.
Yeah.
So we talked a lot about like data, research papers, all this research that's going on. Like I've done some little articles before about how I go about trying to find these papers and research stuff by using like Google Scholar and then I hit a paywall. I got to pay for certain papers. Like what is the easiest way for a general public to consume all these papers and data that's been published out there that could be publicly available? Is there an easiest way to do it, or is it just doing
There's easy, but that's exactly why I'm here, because I was telling Trell that I'm not...
I said,
I
Brock,
don't like this kind of thing. I don't like sitting and talking and where everybody's going to hear. And I know I'm going to make a mistake in what I say, and I'm going to be driving home, and the wildlife chief from Utah is going to call me and say, "Dude, what'd you say this for?" But I've decided that this is where we can reach people that don't do what you're trying to do, and that's go to the literature and read the literature.
Yeah.
But there are easy ways.
Because it's hard to find it. Like I found it is kind of difficult.
It is, but you can go, say you could just log on to BYU's library website and go to their database search, go to the BYU library. There's an icon right on the front that says databases. Click on the databases, pull up Web of Science, type in a keyword, and all the papers on that keyword will come up.
I'd be download, print.
Right.
And just
so there are ways to get it. But I think of sitting in this situation, we've published now dozens and dozens of papers on mule deer and elk, and we're talking about the data that we've found and the results that we've.
Yeah, we're getting a clean summary version of it, which is nice, because a lot of times you read it and they're in depth.
So
I think this stuff is super important. I think just swapping ideas, kicking around, we've talked predator management, we've talked antler, we've talked all kinds of things, habitat. I think all this kind of stuff is just it's so interesting. And I think more people, if we can put it out to more people to just cause them to think, I wonder,
Right.
Like I'd never thought about the idea that you just mentioned of maybe bringing that buck-to-doe ratio down. Mm-hmm. That's got my wheels turning. I sat right here with you and just learned something, so I think that's awesome.
And that's what I'm hoping. I'm hoping that people are thinking and saying, oh, if we're going to try this, why not try it for a couple of years?
Yeah.
If it doesn't work, great. We learned. It didn't work. But if it works, this state, we cut tags, we cut tags. I think cutting tags decreases productivity. Cut tags more, decrease productivity more. Cut tags more, decrease productivity. It's a never ending. Let's try increasing tags and seeing if these bucks on the landscape are competing with our productivity. And see, if you could put 750 more yearlings on the landscape and give every kid that wants a tag
And
they go in and harvest. Everybody doesn't have to kill a 160 buck. I didn't kill one till I was a little older, you know. And I can remember still the excitement when I was a kid. You couldn't hunt big game till you're 16 in the state.
Yep.
And my first year, I killed a 2-point. I can still remember how excited I was harvesting that yearling buck.
Yeah. One thing that I get asked, maybe you can speak to it. I thought maybe I saw a paper that you could either written or contribute to, is the correlation between elk and mule deer. Is there one? Is there evidence to suggest that elk? Because to me, I mean, if you look at it, I talked to my dad. My dad moved to Utah. He hunted mule deer. There were mule deer. And then, you know, there were a few elk here and there, and he would go out and hunt elk. And then over time, you see this like correlation, elk going way up, mule deer kind of coming down. And I think the natural reaction is to say this is causative, right? And, you know, cause and effect. Is there any evidence to suggest it?
Nobody knows.
Okay.
So there have been studies. There was a study done at Starkey Research Station in Oregon that showed that elk were able to physically displace mule deer. There's a study out of Wyoming that shows there's very little diet overlap. We did a study out on the Book Cliffs that showed that deer that gave birth closer to elk habitat had better survival than deer that gave birth further away from elk habitat. I think that the results are completely mixed. The only way to really know is to go in and manipulate the elk population size like we kind of did with predators,
just test it out.
and see if you can affect a change on the deer population. It makes sense. A lot of people believe it is. I mean, but there's nothing out there conclusive saying that it's happening. And you say deer have come down. Well, we're down to like 300,000 deer in Utah. Elk have gone up. We're up to like 80,000 elk.
Yep.
You know, there's still 4 deer for every elk on the landscape.
Yep.
Even though you may see more elk, they're way more visible. But
It's just charismatic megafauna.
charismatic megafauna.
Just giant school buses walking around.
I call them the maggots of the mountain, buddy.
That's what he calls them.
Yeah, they're noisy frat boys. They're out there bugling all the time, scaring up. I'm trying to enjoy my mountain.
Don't get me wrong. I love archery hunting for elk. But the one thing we've learned about elk is the only thing that kills them is lead or an arrow. That's it. They don't die.
They're hardy.
Kind of true.
They are hardy.
Really
and even that sometimes
doesn't do it.
That's right. And so, I mean, elk have about 95% annual survival.
94
to 95% if you take hunting harvest out.
What's the survival of a calf elk? Is it about the same? Is it that high?
No, it's way less than that.
Okay.
So we haven't done as many. We've probably only done, I don't know, 150 calves now, but it's more like 60% survival from a calf to a yearling. And then even a yearling is lower than an adult. So a yearling may only have like 80% survival, 82% survival to get to an adult. But once they're 2 years old, 95%, 94%.
Once they make that 2-year mark, they're golden.
They live forever.
They live forever.
They do. I mean, we've caught them on the Book Cliffs that are mid-20s. I mean, they're just
mid-20s. Imagine that.
There was one that they collared with an original Tolonix recollar in Montana that was harvested 2 years ago, and they went back and it was 31 years ago that it was collared. And so I think that's extreme. They don't, but I think they can regularly live into their 20s.
Yeah. Man, that is nuts.
Even this year, we caught gummers. I mean, they have no teeth left. They're just, I don't even know how they're eating. They're just
still doing it.
Gums.
How much time do you get in the field?
Not near as much as I want, but probably more than I should.
Yeah, that's good. Answer. Well said.
During December, we capture a lot of deer. So we usually start the Monday after November. The Monday after Thanksgiving. And this year in the month of December, we caught about 800 deer and 200 bighorn sheep. And then in this past month in January, we caught 201 elk. And there are 4 of us in the state that use the ultrasound to measure body condition. And we usually have 2 crews going, so 2 of the 4 of us have to be out every day. So half of those days. So maybe between and we'll start catching again later this month for deer, and we'll catch another few hundred. So I'm probably in the field doing deer and elk 40 to 50 days a year.
Yeah.
That's remarkable.
It's pretty cool.
Yeah, it's awesome.
Yeah.
Yeah.
The thing I remember is working those stations is I assume you were doing an ultrasound, right? So you'd be pulling hair, plucking hair, and then just running the ultrasound and kicking out data and information. They gave me some just numbskull job of like giving an injection of some sort. Like, I don't know what they give them, but maybe an antibiotic or something. I don't know what.
So we give them a Banamine, which is like Motrin. It's just like a painkiller.
Yeah.
And we also give them vitamin E, which it helps them process the lactic acid. So if they've got lactic acid buildup from the chase, it helps them get rid of it faster.
Yeah. I've never been on one. We're going to one next week in Nevada, sheep capture.
We ought to get you up to one of these guys.
I really want to do a mule one
fun.
badly. I'd love to.
So we'll be starting, I think, the 26th of this month, and we'll have about 2 full weeks. This is for the neonate. We'll be checking for pregnancy. If they're pregnant, we'll be inserting transmitters into their vaginas, and those transmitters get expelled when they give birth.
Really?
And we get an email that says, I gave birth at this GPS location right here.
Never would have thought how that worked.
And,
Did you know that?
No.
and
I
so
knew that.
we go in the next day and we try to catch the neonates. That's how we catch neonates.
Huh. That's absolutely mind-blowing.
Yeah, they did. They put
Why did I not know this?
I don't know. I knew it, but it's just because I've probably talked to guys like him back in the day.
So we've done this to about 700 litters now.
Yeah. Huh. And you guys will start doing that, catching them to then put the implant in, right?
That's correct. So I think we start the 26th of this month, and we'll go through about the 10th or 12th of March.
When do mule deer give birth?
Well, it depends on where you're at.
Okay.
But I would say on average for the state of Utah, it's somewhere around the 13th or 14th of June.
Okay.
It is earlier as you go north, which is a little counterintuitive.
Yeah.
And it's later as you go south. So maybe on the Cache, they're giving birth on average the 7th or 8th of June. And on the Monroe, it's more like the 16th of June, and maybe the Pine Valley is like the 18th or something. So there's about 10-day variation through the state.
Do we know anything about the areas that
We
they select for birth? As far
do.
as habitat and slope?
So typically, we're just publishing a paper on this. Typically, mule deer, not always, but they tend to give birth on southeast facing slopes.
Okay.
And they give birth first thing in the morning.
In the morning.
Not at night. I mean, this is in general.
Yeah.
You have some that are born at any
yeah.
time, but in general, they give birth in between like 6 and 9 a.m. That's the peak. And they're on southeast facing slopes. And I think that's so they're exposed to the sun.
Yeah.
The offspring can dry off quicker.
Yeah.
They warm up easier. They stay warm.
It's like a predator thing too.
I wondered that. Does that heat the ground heating up to spell some of the scent a little bit quicker?
I don't know the answer to that. And deer are very different than elk. So elk will give birth, and about 4 to 5 hours after elk gives birth, she picks up her calf and moves it about 300 or 400 yards.
Gets away from the scene of the crime.
Gets away from the scene of the crime, and then it'll stay in that general area for the next day or 2, 3 days.
Huh.
Deer, they stay wherever they gave birth pretty close.
Yeah, why is it the big difference there? I wonder.
The other thing the elk will do, this is crazy. On the Book Cliffs, a cow elk, she'll be up on the top in that summer range, and we'll be looking at her on the computer where she's at. I can look and see where they're at every 2 hours. And all of a sudden, she'll pile off. She'll move 13 miles clear out onto the sagebrush desert and give birth under a lone cedar tree 13 miles from where she lives. And she'll be out there for like a week, and then she'll bring her calf back up onto the top of the mountain. Not all of them do that.
But some do.
But some do. And you're just going, that's got to be like an anti-predator behavior, that I'm moving this thing off
I'm
of
getting
this.
it out of the scene. Yeah,
How did it learn that, and why does it go so far?
It's so cool. But yeah, so on elk, when we get that vit notice, we try to go in. Usually, you hear people say, oh, they're going to abandon their offspring if you get human scent on them. We've never had that happen.
Not the case.
Not the case.
But
it is possible if you go in before they imprint, but they only need about 3 or 4 hours to imprint. So by the time we get a notice and we get ready and we go in, it's been 4 hours. So if the offspring is dried, they've already imprinted to their mom and it's fine. We've never had a single problem.
So you guys are you like taking photos of these sites too to look at like habitat elevation? You're talking about slope aspect.
We have all that. We have to take a GPS location of all of them. And that's how we know that for deer, they tend to be on southeast facing slopes. And we know what time we get that vid expulsion, so we know what time they're giving birth in the day.
Does that come in an email or text message?
It comes in an email.
Really?
Yeah.
So
Must be so exciting to like,
everybody's on alert that week, right? Like everybody's waiting for them.
So yeah, you're checking multiple times a day.
Every day. So
about in deer, I'd say 80% of the births happen in about a 10-day window.
Gotcha.
We have a couple early ones and a couple late ones, but usually, say on the cache, they start giving birth about June 1st, and they're basically done by the 15th.
Is that for elk also?
So,
because elk, everybody talks about the second rut. So you've got the primary rut happens in September, all the elk get bred, and then you've got the secondary rut, so those late cycle cows. Is that the case? Are there calves being born later into the summer?
Maybe.
Okay.
So we have very little evidence. We have no evidence of that in deer. So I hear people say all the time that, what about the second rut? We have a single peak and all the births happen around that peak. Elk are spread out more. And it's dependent upon the condition of the females. So the better condition the females are, the more truncated or punctuated the birthing is. And the poorer the condition the females are, the more spread out it is. And I think it has more to do with them coming into estrus than it does maybe a second rut. So I think that they have to be in a certain level of condition before they'll ovulate.
I never even thought about that.
And so if they're all in really good condition, they all ovulate at this prime time, and the ruts are really punctuated. Man, the rut's on.
Yeah.
And if they're
really
in poor
interesting.
condition, if it's a bad year, I think that rut gets spread out more, so it never goes off as hard. And in fact, it may not go off as hard, period. On the Book Cliffs in a bad year, we only had like 56% pregnancy in elk. Deer are always pregnant.
Yeah.
And then the next year that was a good year out there, 87% were pregnant. And so you go, oh, the rut never really went off this year. It didn't. Only 50% of the cows got bred.
That's so wild because you think about, now my mind is spinning. I'm thinking about years where or you talk to people or I've hunted and I've thought, man, that rut felt so late that year, or it didn't feel like it was a good rut at all.
Right.
I never equated it back to the possibility that the cow's body condition was not they weren't in good condition. They weren't coming into estrus, right? Like in a timely manner.
Right. So we know some don't.
Some don't.
A lot of what I'm telling you about here is speculation, but we know that some don't get pregnant, and when they're in poor condition, a lot more don't get pregnant. Yeah. And I'm assuming that's because they never came into estrus.
It would be really interesting to go back and look at droughty years and compare that to what people thought the rut was like.
Wait, you're from Southern Utah, isn't that drouthy?
Drouthy, yeah.
Yeah, it's like what everyone's talking about.
No cricks.
Since I went down to Sonora this year, I've been really paying attention to every single outfit, every single person talking about the rut down there, and everyone's like, it's almost non-existent. Like they're not seeing it all. And it was like the worst drought they've ever had in 50 years. Like they're not seeing bucks rutting, not seeing, doing anything with coos and mule deer.
Yeah.
So it could be one of those things where they said body condition, does just
didn't come into estrus.
So we have very little evidence that happens in deer, but the only time we do. So we've done 27 units in Utah for the last 13 years. Not every unit every year, but basically down on the San Juan. I don't remember, a few years ago it was extreme drought 2 years in a row, and the second year of that extreme drought, only, I don't remember the exact number, but only like 87% of the does were pregnant. And so there was a potential effect of multiple drought years in a row on pregnant. But every other unit, 94 to 97% every year, regardless.
So you're saying it happens more in elk than it does in deer?
So in elk, it seems like they have a different strategy. I think deer make the choice whether to reproduce after birth.
Because they're a fair species.
and elk make the choice at time of getting pregnancy. So this year on the LaSalle Mountains, after last year's winter, literally 18% of the does walked away from their fawns after they gave birth.
Wow.
We've never seen anything like it.
Yeah.
And I think they made it through winter as just fumes. And when it came time to nurse, they said, I just don't have it. Either I nurse and die, or I choose to live for another year. 18% of them walked away.
Nature is metal.
Yeah. Wow. Man, this has been fascinating. You've got my wheels really turning today, so I appreciate you coming.
No, I love it.
Yeah. Anything else that you're working on right now that you wanted to talk about, you wanted to plug, or?
Oh, geez.
I'm sure there's nothing else going on, right?
No, we're just doing, we welcome anybody to come to the captures. So you guys want to come to the captures. I think the division, so we do this in coordination with the division. Again, I want to shout out, I think Utah's Division of Wildlife is excellent.
As do I. I agree. And
I think they are proactive.
Yep.
They adaptive manage. And they really care about deer and elk. I hear people badmouth them all the time, and I just think it's wrong. I think they are trying their hardest. Yeah. They have the better data than any other state, in my opinion. They're doing more to try to understand it and to try to help our wildlife. And so I think they welcome the public. If you want to go, I just call the regional office and say, when are you guys catching? And they will say, come out and see what we're doing.
Yeah, I'd love to just be there and help and see it all happen.
We should go do it, Brady.
Yeah.
You get to handle some muleys.
So
we'll give them back.
Since you never kill any in the fall, right?
Yeah, exactly.
Just kidding.
Well, anybody can kill an elk if you go after a deer.
Yeah, I know. I killed a big bull this year. It's the easiest thing ever.
Touche, Brock.
Yeah. But I will say, we've had a lot of guests on, and this is probably my favorite podcast literally of all time.
Oh, I appreciate that.
And we could probably keep talking for hours and hours, but this is a lot of good information, a lot of really in-depth stuff. And it's going to make me want to go back and listen to it and write down more notes. Because like the trail said, I'm thinking the whole time. It's like, whew,
yeah,
just want to soak it all in.
When we were kicking around ideas of coming to the expo and doing podcasts, I think somebody had asked within Slack. They said,
I posted it.
Brady had posted one of your posts.
Instagram.
And I said, "Oh, I know Brock." I said, "We could have Brock on." I think.
I was Brock, like, "Trill, you've been hiding this gem of a person from me for all this time."
I think Brock would come on the podcast. So then I hit you up, and I was really appreciative that you were willing to do so.
So I'm always hesitant, but I'm happy to do it because I think it's really important. I think that the more people learn, and I'm not saying we're always right. We could be wrong on some things. Hopefully, I didn't say things definitive. This is it, but based on the data, I tried to tell you guys what we think's going on, and I'd love to come back anytime and talk about other things.
Yeah. I was going to close out. I told you I had one more.
Okay.
If you had the ability and you could just, you could produce mule deer, we're talking like from this point forward. And again, we've already prefaced it and said that every unit's different. It's got its own kind of things on, but what kind of conditions would produce mule deer? Would put those back into a growing, healthy population?
So I think we've seen this. We see it on the Pingwich fire. Okay. We see it on the Sealy fire. We see it on the Nebo fire. We see it on the North Manti fire. I just think that first 10 years after fire.
First 10 years.
First 10 to 12 years after. We saw it on the Henry Mountains.
Yeah, boy, did we.
And I just think that first, even up to maybe 14 or 15 years after fire is phenomenal. And then we start getting that late cereal stage and it's not nearly as good. I mean,
So fire.
In my opinion, fire at high elevation.
I love that. It's a great answer. You nailed that. You passed.
Oh, geez.
That's the first time I've ever got to grade a professor. You did instead of them grading me.
Oh, I get graded every semester, buddy.
Any others for you?
No, I'm just mind blown that we got to sit down and do this. I feel pretty special that we got to
I really appreciate you taking the time.
You bet.
Take up some of your time, which I thank you for coming by and doing it.
No, I needed a reason to come up here, so.
Yeah. All right. Well, thank you.
Thank you.